Today we will be learning about greatest common factor and least common multiple. Feel free to pause the video at any time to continue working on problems or writing notes. If you are confused, you can go back in the video to rewatch parts. Materials needed. You need your worksheet, which is front and back, a pencil, a whiteboard and marker, or you can use scratch paper, a calculator, and a partner. Let's start. What are factors and multiples? Factors are numbers that make up your starting number. For example, what are the factors of 24? I know 1 times 24 equals 24, 2 times 12 equals 24, 3 times 8 equals 24, and 4 times 6 equals 24. So I know that the factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. Multiples are numbers found by multiplying your starting number by another integer. For example, what are the multiples of 5? I know how to skip count by 5, so those are the multiples. 5, 10, 15, 20, 25, 30, and 35. How do I remember all of that? I like to think of factor ninjas and multiple monsters. Factor ninjas chop numbers up into their smaller parts, while multiple monsters like to make numbers bigger. Let's watch an example. Here's a factor ninja at work. I'm a factor ninja. I like to chop numbers up into their smaller parts. I know 56 is divisible by 2 and 28. 28 is divisible by 2 and 14, and 14 is divisible by 2 and 7. So I know 56 is 2 times 2 times 2 times 7. Now let's see a multiple monster in action. I'm a multiple monster, and I like to make numbers bigger. For say for 15, I'm going to count by 15s. 15, 30, 45, 60, 75, 90. Let's start by finding the multiple of a number. When finding the multiples, I remember a multiple monster, so I know that I'm going to be making numbers bigger. To find the multiples of a number, you can skip count by that number, use repeated addition, or multiply it by other numbers. Now we're going to do an example of 10 and 14. There are endless numbers of multiples, but in our examples, we only listed 10 of each. Follow along and feel free to write down the example on the spot in your worksheet to help you later on in the lesson. For our two examples, we are going to do 10 and 14. For 10, I'm going to use the first strategy we discussed, which is skip count. So to skip count, I'm just going to skip count. So 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. For 14, I'm going to use the second method which we discussed, which is multiplying as I go. So I'm going to look at 14 times 1, which is 14. 14 times 2, which is 28. 14 times 3, which is 42. 14 times 4, which is 56. 14 times 5, which is 10. 14 times 6, which is 84. 14 times 7 is 98. 14 times 8 is 112. 14 times 9 is 126. And 14 times 10 is 1. Find the least common multiple, or LCM. The least common multiple of two numbers is the smallest multiple they both have in common. I just found the multiples of 10 and the multiples of 14. So now I'm going to find the least common multiple. I do that by looking for the smallest number they have in common. Hey, look, they both have 70. If I had continued listing the multiples for 10, I know we would have also have had 140 in common.
Since we are looking for the smallest number they have in common, 70 would be the answer. So 70 is the least common multiple of 10 and 14. Try it yourself. Throughout these examples, you can use your calculator as needed, and if you're using a whiteboard, don't erase so you can use your information later on. First, list the first 10 multiples of 6. Pause the video and get to work. Welcome back. Now, list the first 10 multiples of 16. Pause the video and get to work. Now, use what you have and find their least common multiple. Pause the video. And now that you have found your least common multiple, share your strategy with your partner. Now it's time to check your work. Okay, now we're going to check our work of 6 and 16. First, we're going to find the multiples of 6. I could do this in many different ways. I could skip count, or you can multiply, whatever you feel like, but I'm going to skip count since it's pretty easy with 6. So 6, 12, 18, 24, 30, 36, 42, 48, 54, and 60. I went to 60 because the instructions told us to go to 10 numbers. So for the next one, I'm going to do 16. And for this one, it's a little harder to skip count, so I'm going to either do repeat addition, adding 16 as you go, or kind of look at it as multiplication. I kind of looked at it as adding 16, so it's kind of like the aspect, so it'd be 32, which would be the same as 60 times 2, and then it'd be 48, 64, then it'd be 80, 96, 112, 128, 144, and 16. And again, I went 10 numbers. And now we're going to do the least common multiple. So I'm going to look at my two sets of numbers and kind of see what is the least number that I see, the least multiple. So as I kind of look around, I don't see much in common until this one, I can tell that I have to go a little further to find something. And I see 48 and 48. And I can look again to check, and 32 is not there, and 16 is not there. So that would be the least common multiple.
What's a prime number? A prime number is a number whose factors are only one in itself. Some prime numbers include 2, 3, 5, 7, 11, 13, 17, 19, 23, and a few more. Remember, 1 is not a prime number. We can use prime numbers to find the prime factorization of a number. Knowing prime numbers is a very important skill, but since we're focusing on finding greatest common factor and least common multiple today, you have a hint on the bottom of your worksheets with a few of the prime numbers included. What's the prime factorization of a number? The prime factorization of a number can be found using a factor tree. I remember factor ninjas like to make numbers smaller, so let's watch this factor ninja finding a factor tree. There are multiple ways to do it and you'll get the same answer, but follow along during this example.
I'm going to do an example of a factor tree. Let's start with 36. I know 36 is divisible by 3 and 12. 3 is a prime number, so I know 12 is divisible by 2 and 6, and 2 is a prime number, so 6 is divisible by 2 and 3. So I know the prime factorization of 36 is 2 times 2 times 3 times 3, because those were all the prime numbers that I found. Let's try another one with 42. I know 42 is divisible by 2 and 21. 2 is a prime number, and I know 21 is divisible by 3 and 7. And those are both prime numbers also. So I know 42 has the prime factorization of 2 times 3 times 7.
Now let's talk about finding the greatest common factor, or GCF. The greatest common factor of two numbers is the biggest factor they both have in common. To find the greatest common factor of two numbers, we can use the prime factorization to find what they have in common. I just found the prime factorization of 36 and 42, so now I'm going to find their greatest common factor. Remember, 1 isn't a prime number, so that's why it's not in my factor tree. After looking at the prime factorizations of both numbers, I noticed that they had a 2 and a 3 in common. So I know that the greatest common factor of 36 and 42 is going to be 2 times 3, or 6. Now let's try it yourself. Remember, if you're using a whiteboard, don't erase your answer during this because you'll use it later. First, find the prime factorization of 30 using a factor tree. Next, find the prime factorization of 84 using a factor tree. Finally, using both of your factor trees, find their greatest common factor. Now that you've found the greatest common factor of both of these numbers, talk with your partner and share your strategy. Let's check your work.
First, we're going to start by using a factor tree to find the prime factorization of 30. I know 30 is divisible by 3 and 10. And 10 is divisible by 2 and 5. Those are all prime numbers, so I know the prime factorization of 30 is 2 times 3 times 5. Next, let's try the prime factorization of 84. I know 84 is divisible by 4 and 21. And 4 is divisible by 2 times 2. And 21 is divisible by 3 and 7. So I know the prime factorization of 84 has to be 2 times 2 times 3 times 7. So now that I have the prime factorizations of both numbers, let's see what they have in common. So I know they both have a 2. I know they both have a 2 here. And I also see they both have a 3. That's all they have in common. So I know the greatest common factor has to be 2 times 3, or 6. So the greatest common factor of 30 and 84 is 6.
Put it all together. Now we're going to play a game to help practice these. The bingo cards are found on the back of your worksheet.
There will be a problem shown on the screen. Pause the video to work and find the answer.
When you know the answer, find it on your bingo sheet and circle the correct number.
Once you've found your number, you'll have to complete the number sentence. So circle if it was the least common multiple or the GCF and fill in the rest of the sentence.
You probably won't get through all these problems, but that's okay. If you forget how to find one of them, go back in the video and watch an example.
Start by crossing off your free space and we'll get started. Good luck!
Find the least common multiple of 5 and 9. Remember that you can look in the corner and it'll show you that the multiple monster, which means you're going to be making the numbers bigger. Pause and get to work. Your answer should look like this. I circled the 45 because that's what I got as my answer. I was finding the LCM, so I circled that. And the two numbers that the slide gave me were 5 and 9, so I filled that into my number sentence.
So your answer says 45 is the least common multiple of 5 and 9. Now find the greatest common factor of 15 and 40. Pause the video and try it out.
Now find the least common multiple of 4 and 6. Pause the video and get to work.
The factor ninja's in the corner, so remember you're finding the greatest common factor of 18 and 24 this time.
Now find the least common multiple of 6 and 8.
Find the greatest common factor of 18 and 16.
Find the least common multiple of 9 and 12.
This time, find the greatest common factor of 30 and 9.
Now find the least common multiple of 5 and 8.
Find the greatest common factor of 40 and 50.
Find the least common multiple of 2 and 9.
Find the greatest common factor of 14 and 21.
Find the least common multiple of 5 and 4.
Look for the greatest common factor of 63 and 54. Is anyone getting close to a bingo?
Find the least common multiple of 4 and 7.
Find the greatest common factor of 20 and 12.
Find the least common multiple of 5 and 3.
Find the greatest common factor of 42 and 63.
Find the least common multiple of 6 and 5.
Find the greatest common factor of 28 and 42.
Now, find the least common multiple of 4 and 8.
Find the greatest common factor of 64 and 48. Has anyone gotten bingo? See if you can get a blackout on your card.
Find the least common multiple of 12 and 16.
Find the greatest common factor of 44 and 33.